Yaskawa. You're watching the IEC 61131 Basics video tutorial series. In this video, we'll make our own customized function block. Hi, I'm Matt Pelletier, and I'd like to explain the concept and then ask you to follow along with me through the steps of creating a function block and implementing it in our project. I'll give you some troubleshooting tips, and then we'll improve the block by adding an enable input and our own right-click help. So let's start off with the concept, which is that in our main POU, we would like to add a function block called YTTS blinker. And we'll have to create the code internal to that POU, that function block POU, and it will have inputs called off time MS, on time MS, and then an output called Q. As we did with the function, we'll use this prefix YTTS, which by the way is Yaskawa Technical Training Service. And we put this prefix as a best practice to avoid name conflicts and to organize. There may be a blinker of some other sort in a library that we'll use later on, and but there's probably not going to be another YTTS underscore blinker. And so if everybody would put a prefix, then we would be able to use libraries and function blocks from different sources within the same project. Also remember that a function block has more than one output, and those outputs calculate over several scans. Here we're using timers, and so time is involved with this. And so there will be an instance name for every one of these blocks that we use. And these instances allow it to run separately from the other instances. Let's understand here what we want exactly this block to do. We want the output Q to cycle on and off according to the on time and off times, kind of like a PWM signal if you're familiar with that, but we'd like to give it on time and off time, and then it just has this output here that turns on and off for the two times that we've specified. And so you will have to now insert a function block POU to your logical POUs, and you can refer to this page to create this code. And I'd like you to try this by yourself. Just refer to this page and look at some of the variables here have an initial value. We're using double integers in this case for the times in milliseconds. And another trick we're using, in addition to the negate input, which we've covered, that's the properties, is we're changing the name in the properties of the instance, and then we're using the name with the .q notation. Any of the inputs or outputs can be referred to by using the name of the instance followed by a dot and then the name of that input or output. So we're able to take onTimer.q, which is this one here, onTimer, the q output .q, and instead of drawing a line back up to it, you could just take it directly without creating any type of intermediate variable. So for you guys who have been through the other videos, I hope that you already know what to do, and if you could go ahead and take a minute to try this out. So pause the video, and if you need a hint, then you can play it and you'll see my solution here coming up next. So I'm going to make YTTS blinker, leave debug mode, and I will insert into my logical POUs the function block, naming it YTTS underscore blinker, and I will use LD, ladder language. Okay, so now we'll open up YTTS blinker code page, worksheet, and let's start with the off timer. We have a dint to time, and I think I will not use the en and eno under my objects menu. Turn that off and update. The into time going to, let's put down a t-on timer. And we want to connect those here to the PT input. And I wanted to change the name of this instance. You could use the word t-on too, but let's just make it clear. It's an off timer. And I'm going to connect an input here, which is the off time in milliseconds as a double integer. Okay. This should be a var input. Okay, var input. And then this whole assembly, I'll have something very similar to it. So I can copy it, paste it. However, I'll need to update the name of the instance by double clicking on here. I wanted to call it on timer. And this input was called on time _ ms. Also a var input. So there are my two inputs here. And I have one output, which I will call Q, and it's this one right here. So call it Q, and that's a var output. Okay. Now within this function block, I will have two intermediate variables. One is the elapsed off time, and that's not a var output. It could be. I'll just have it as a var. And the elapsed on time, also as a var. And the trick here is to take the on timer's output Q as the value for the off timer. So we put on timer.q. Notice that .q, and it recognizes that that is a special character and grays out the rest of it. So I got on timer.q. And this was off timer.q. So similar to taking the output and wrapping it back around, it's just a little more efficient and shows another way to program. And I missed one thing, which was we wanted to look at the off timer, the on timer being not on. So we're going to double click here and negate this input. Negated puts that little circle. And then I know that we're looking at this output being not on will cause this timer to start. And this will cause it to hear ping pong back and forth. And we'll get this output Q to turn on and off. So we can do a make or a check for easy errors with compile worksheet. It's real quick. Okay, got no errors in there. And I'll do now a whole make. And then back in the main POU, just moving down here, I'll put in from my group, I now have YTTS blinker. I missed one thing, which was I missed the initial value just for ease of use. The initial value of these timer on time and off time, I had wanted it to be an integer. So type dint pound 1000 for both. Start with 1000 milliseconds. And let's download that change. Great, now we'll close the resource and back to main. I'm running this code. And I notice it was able to download without any of the inputs or outputs connected. This is one of those properties of function blocks. However, that's unfortunate for me because I did need to put something on here. So let me put a variable here. Now I was going to call this here light off time. And light on time. And then here this one, looking ahead to what we'll do next, I'm going to make this a global G underscore light output. And I'll make that a var global in the user variables. And one more download changes. And close the resource, go to debug mode, let's test this out. And it looks like I'll need a warm start for that initial value to take place. I'll do stop and warm. You know, I don't have an initial value for the, let's give these also a 1000. And now we have 1 0 1 0 turning on and off, 1000 and 1000. As just to prove that it's working, maybe I'll do 2000, tab overwrite, and I'll have it be on for just 500, tab overwrite. And now it's believable that we're doing 500 milliseconds on and 2000 milliseconds off. I've got a blinker. Let's take a minute to review how this is operating and how this is executing. We are taking, whether it's temperature or blinker, we're taking that POU, running it in the main program POU, and the main program POU executes in the task that it is in. And before we go on to drive the simulator output, let's look at a few common troubleshooting issues that some of you may have. And one of them is the input names and the input order. This goes for functions or function blocks. And if you have any type of stray input variable, then it's likely that it exists in the variable list. So if you have a variable in the variable list, look in your POU. I'm using temperature here, YTTS temperature as my example. Look in that variable list, open it up, and if there's something that maybe you typed by mistake, just delete it, and you'll have to then recompile. And another detail is the input order, as far as how the block looks cosmetically, is defined by the order of the inputs in this variable list for your function or function block. So to make them appear in the order that you want, just move them into the order that they should appear within the variable list, and then recompile. That update of the input order and appearance of inputs will not update the existing blocks in your code. You don't have to delete and put them back in, though. You can right-click Update, FBFU, and the updated version will then be inserted in place. Now let's add a little feature to this block where we actually make a light to turn on and off. Maybe for a parking garage example, this could be a warning light. But let's review how you would put those to drive a real output. And we'll also see how we can put in multiple instances of the same block. And you can have two blinkers operating completely independently because they have their own instance. So take a minute here and see if you can do that. You will need to update the main program POU and also the input and output program POU to connect these global variables to the IO variables. So if you would please take a minute to do that, and you can pause the video. Okay, I will now add another blinker function block and use that to drive two of the lights here. So debug mode is off, and I'll put in another instance of YTTS blinker. So there it is, and I'll call it light off time number 2. Oh, I did not want global. I wanted var. Except now I'm going to have this instance, this scenario. So I'll need to go edit my global variables. There it is, light off time 2. To delete that one out of there. And back to main. Light off time 2 will be var, not var external. And I don't get the message because there's no more global variable with that name. All right, next was light on time number 2. This time I won't make that mistake. I'll go here to var. But I do want a global here for light number 2 out. Light. So G light output on number 2. This will be a var global in the user variables. All right. So there's this code. But what makes me think that these global variables will truly turn on and off a hardware output? Well, we have an output for this PC simulator that we created in one of the earlier videos. So I'll go to refresh my memory in that code, and I just have one line here, G-gate open and DO0. Well, now I have two more outputs I want. So I'll just make another network, and I'll use G underscore light output for one. And I'll make another one here with G underscore light output and go arrow down here to output number 2. And let's just go in order here. I'll use outputs number 1 and 2. So I want a DO underscore 0, 1. Now I can see that this does not exist yet. I could create it in the global variable list, but if we remember here, our addressing, %qx0.0, well, output number 1 is %qx0.1, and that's a PC simulator group output. And next here, DO underscore 02 will be at address %qx0.2. Boolean var global under PC simulator organizational group. So let's download these changes. And the controller is running. Close the resource and try out debug mode. I think we can see already I've got this one going crazy because I haven't set the time yet. So I'll go in here to main and I'll set this here. Maybe I'll have a fast one and a slow one. This one will have 200 milliseconds. Let's just do straight 200 and 200. So now I do have one fast blinker and one slower blinker. The global variable is tied to my ladder outputs, and those outputs have hardware addresses which interface to the real world, in my case the PC simulator. And you can see that both of these operate completely independently. The final code development that I'd like to share in this area of function block is how we could make an enable input so that we could start or stop this blinker. And just to overview what we have here, we've already have this area here we already have done. This is the core of the blinker. And what we'll do is we'll add an enable input, and we'll use an internal active variable. We'll also use a jump. And so if we're not enabling, then what this does here is it will jump to the end, the bottom of the code, and just skips everything. So we don't even execute any of this code. The rest of this code here, rung number 2, we're taking the case where we have enabled, but it's the last scan through, which we're creating with this rung down here. And the purpose of this is to reset everything back to 0. We'll take a false and move it into the output and put 0 time into both of the elapsed times. We don't want to just leave it here and leave everything frozen. I'd like when I disable it, that when I re-enable it, it starts over and doesn't just pause essentially and pick it up to where it left off. So this is kind of a best practice, a way to put an enable into your block. A little hint here before you get going on your own on this is to get this jump, you need to right-click. Right-click, insert jump, and this is right-click, insert label. Just be sure that they have the same name. You'll be able to type that name in. And I think the rest of it you will be able to do. So, as before, if you could please try this code and pause the video at this point until you want to see my solution. All right, leaving debug mode, let's go to YTTS blinker, and we'll start up at the top here. I need some room, so I'll right-click, insert rows, so that I can add this network. And I don't really need the coil, so I'll delete the coil and delete that power rail. But what I do need is I need another contact, because one contact was going to be for my new input called enable, which will be a var input. And I'll make that one normally closed. And now an internal variable called active, which is just a var. And I'd mentioned you right-click to add a jump, so I'll right-click, and it says here connector jump, and I'll call it jump number 1, and you choose jump. So this jump can be put right on the ladder code like this. Active should also be normally closed here. So I'm saying if I'm not enabled and I'm not active, then just jump down here to the end. And I think I'll make this jump down here at the bottom. You just right click, connector jump again, and this time choose the label, and that label can just hang all by itself. That's just a point in the code for this jump to take the execution down there. Next, I want a rung that will clear out the elapsed on time and off time and clear the output queue when I disable. So let's just take this rung and I'll copy this portion of it and then come down here and paste it. I didn't get that jump this time. So I want to know when I'm not enabled, but it's still active from the previous scan. And now I'll use the move function called move. Except I do need the enable input on this one. So again, under the objects menu, we'll use en and eno again, and I'll update this one. So I want to move to my output queue the value of false. Let's slide this over, because I also want to move the value of 0, t-pound 0, into my elapsed off time, and also move zero into the elapsed, pressing down here, elapsed on time. And then we can string these together here in such a way that this happens only if I'm still active and the enable has been removed. And then finally, down here we create the final rung. It is important that this rung be at the bottom. We make enable turn on active. So logically now, when enable is turned on, the first thing that will happen is it will turn on active. And then the next time we scan through here, it will not jump over, because enable will not be off anymore. It will be on. So we will not jump. We'll start to do our code, and enable will still be on. So this code will not run, because now an active is on and enable is on. And then when we eventually turn enable off, it will start the code at the top. Enable will be off, but active will still be on. And so it will not jump. It will get down here. Enable's off, active's on. It will move all of this data. And then finally enable, which is now off, will write active to false. And the next time then, none of the code will execute. So the true test now is to do download changes. And I have errors because it doesn't like my t-pound 0 s for seconds. Shame on me. The other thing too is I guess we need to update the main POU. Let's update these YTTS blinker. Because we don't have the enable here. And you know, here's a case where it put enable at the bottom. And I had mentioned, why is that? It's because it must be at the bottom of the list. So good, we get to prove all this stuff. There's enable at the bottom. So I will move it up to the top. And we'll need to make again. Now in the main, I can right click and update it. You know, it didn't put the enable to the top. I believe that this is because I have items connected to it. So let me use shift to take those out. And let's do update. Okay, what if I put in a new one? YTTS. All right, I guess maybe you do need to delete it. Don't remember that functionality working that way before. But we can delete it and put it in here. We now have our light on time, light off time, and the enable. Do the same thing in this one. I'll just delete it because that's easier. YTTS blinker. And put the pieces where they go. Enable number 2. And let's download these changes. Seems that sometimes download changes produces this watchdog error. This could be based on my scan times. Maybe need to raise those up a little bit. Or just a warm start, and it seems to work okay. Now in debug mode, you can see now that my output are not turning on and off anymore. But I can enable it. Give it some time here. And that allows me to enable and then disable to turn that blinking off or back on and off. Okay. The last feature we'd like to show you is for adding your own help for your own functions and function blocks. Right now, if you were to right click on any of these customized blocks, there is an option for help, but it's completely blank. So the way to add help here is that this info worksheet, which we really haven't used so far, this is your chance to use help. It's a text help. And so I could just type in here, blinker has on time in milliseconds and off time in milliseconds. Just as an example, back in main, if I right click on this for help, I don't see it until there's a successful make. So now that there's been make, I can right click, look at help, and I'll see the textual help that I wrote into this worksheet. It's also possible to insert, you right click on the eye here right on this worksheet, and you can insert another description worksheet. Call it maybe here detail. And I could put more help detail here and make. Then when I click on the block for help, there will be a next button and a previous button to look at those two pages. So great for documentation, and this also then allows you to lock. If you go here to lock your code under a file, enter password, you can lock your code, but that help will still be visible when you right click on it. So this method gives you text-based help only. If you want more interactive or pictorial help, HTMLs can be used. And so I'd recommend you just look at the And the help for MotionWorks IEC explains how to make help with an HTML file. Just go to the help contents and search for HTML. And you'll see here calling help on functions and function blocks, how to set up an HTML file. And so we'll leave this to you to look at as you create help for your own customized function blocks.